You see one of those colossal ships gliding across the ocean, and you gotta wonder, right? How on earth do you build something that big? It's this incredible journey, really, taking a totally flat, simple sheet of steel and turning it into this massive vessel, ready for anything the sea can throw at it. Well, that's exactly what we're gonna break down today.
All right, let's get right into it. The whole thing kicks off not with a bang, but with data. Yep, just pure information. A complex 3D model living inside a computer. And from that digital ghost, you get, well, a floating city. It's a mind-blowing testament to what we can build. And that's the story we're telling.
So, first up, the ship on screen. We're talking design and planning. Because, before a single piece of metal gets touched, before you hear any welding or see any sparks, the entire ship already exists. It's all right there, perfected in the digital realm.
The thing to really get here is that nothing is left to chance. It all kicks off with what the owner actually needs. Then the naval architects, these brilliant minds, they translate those wishes into an incredibly detailed 3D model. But you can't just build from that. Oh no. The design has to get a stamp of approval from what's called a classification society. Think of them as the ultimate safety inspectors, like Baroque Classification Indonesia. They make sure everything is up to code. Only after they give the green light can you move on to the production plan, where the real magic of breaking the ship down begins.
And that brings us to this absolutely game-changing idea, block division. So, what is it? Think of it like building with giant Legos. Instead of starting at the bottom and building up, layer by painful layer, which would take, forever, they build huge chunks of the ship all at the same time, in different places. It's all about working in parallel. And let me tell you, it's a massive, massive leap in how fast you can get things done.
Okay, so we're done with the digital world. Let's head out to the workshop floor. We're talking about forging the giant's pieces, steel fabrication. This is where things get real, where raw steel gets turned into the building blocks of this massive vessel. Now, this first physical step is absolutely 100% critical. The raw steel that shows up at the shipyard is covered in this stuff called mill scale. It's this flaky, brittle layer, and it's terrible. It traps moisture, causes rust, and paint just will not stick to it. So what do? They blast it all off with tiny steel pellets. It's called shot blasting until it's perfectly clean. And then, immediately, they slap on a special shot primer. This isn't just about making it look nice, it's literally preparing the steel's immune system to survive decades of abuse from salt water.
And here it is. This is the moment where all that digital data finally becomes a physical thing. Those 3D design files, they get fed straight into these enormous CNC plasma and laser cutters. It's amazing to watch. These machines just trace and cut out thousands of different parts from these huge steel plates, and the accuracy is just insane. And the scale we're talking about is just staggering. Remember those Lego blocks we talked about? Well, a single one of those, once it's all welded together from those precision-cut pieces, can weigh up to 500 tons. That's like the weight of 3 blue whales for just one piece of the puzzle.
All right, so we've got our giant puzzle pieces. Now for the really cool part, assembly and outfitting. This is where the giant actually starts to take form. It's where this empty steel shell gets a heart, a brain, a whole nervous system.
The saying in the shipyard is all about precision on a massive scale. Think about it. The whole structural integrity of a ship that's hundreds of meters long. It all comes down to how perfectly you place that very first block. We are literally talking about getting it right down to the millimeter. It's that critical.
So this whole assembly stage is called the erection process, and it follows a super strict sequence. It all kicks off with the keel laying. That's a big ceremony where they lay down the very first block. After that, these huge, powerful cranes lift each 500-ton block into place. Then the surveyors come in, checking everything with lasers to make sure that alignment is millimeter perfect. And only then do the welders come in to fuse these massive blocks together. You can literally watch the ship grow, section by section.
Right, so a hull on its own is really just a big, empty steel shell. Outfitting is what brings it to life, and man, is this phase labor-intensive. We're talking about installing kilometers, literally kilometers, of pipes and electrical cables. The main engine, this massive beast, gets carefully lowered in, all the navigation gear, the safety systems, the living quarters, everything gets fitted. It's seriously like building an entire industrial city, all contained within that steel frame.
Okay, we're getting close to the climax now. This is the moment of truth. The birth of a vessel, launch, trials, and purpose. This is where a construction project stops being a project and becomes a ship,
ready to meet the sea for the very first time.
Now here's something most people get wrong. That paint job on a ship? It is not for looks, not at all. It's actually a super high-tech, multi-layered defense system. You've got layers of anti-corrosive paint that are the first line of defense for the steel. Then, on top of that, you have this special antifouling coat that stops barnacles and seaweed from making a home on the hull. This isn't decoration, it's a critical part of the ship's engineering.
So that brings up the big, dramatic question, doesn't it? After all this time on dry land, months, maybe even years of work, how in the world do you get a 50,000-ton steel structure to meet the sea for the very first time?
Well, before it can be handed over to the owner, it has to pass its final exam, and that exam is called the sea trials. They take the ship out to the open ocean and they push it to its limits to prove it can do everything it was designed for. Can it hit top speed? How sharp can it turn? They even do this wild test called a crash stop. They literally throw the engines from full speed ahead to full reverse to see how fast it can stop in an emergency. It's intense. And only when it's passed every single one of these tests does it get the final certification.
So all of this incredible engineering, let's connect it to a bigger picture, a national purpose. Let's talk about this number, 17,500. What is that? Well, that's roughly how many islands make up the Indonesian archipelago.
And that really gets to the heart of why this all matters so much. When you're a nation made of islands, ships aren't just a nice-to-have. They're not a luxury. They are the roads, the bridges. They're the fundamental infrastructure. So having a strong shipbuilding industry at home, with companies like PT PAL Indonesia leading the way, isn't just an economic plan. It's a strategic lifeline. We're talking about creating jobs, building up incredible engineering skill, and, maybe most importantly, achieving strategic independence.
Which brings us to one final question to think about. As a nation like Indonesia continues to master this process, moving from building simpler ships to tackling more and more complex ones, what do you think is the next big step? What's the next great challenge for a country that's building its entire maritime future on a foundation of steel and just sheer ambition?